So for number 41, we want to find out if the sequence over here, if it converges. And now a sequence an converges if an tends to a limit as n approaches infinity. So we're going to take the limit of the sequence and see if we get a defined number. So we're going to take the limit as n approaches infinity of n squared e to the negative n, which is the same thing as taking the limit as n approaches infinity of n squared over e to the n. And so if we take this limit, infinity squared is just infinity over e to the power of infinity is infinity. Now, this is an indeterminate form. And if you remember when we worked with the derivatives, we deal with indeterminate forms using L'Hopital, right? So what we're going to do is we're going to approximate using a function. So if we take a function, for example, the sequence 1 over n and the function 1 over x, what's the difference? Well, if I have my x-axis here, my function is going to go 1 over x to my function is going to be continuous, whereas my sequence is just going to be defined at the natural numbers, right? So we're just going to have these dots, and they're not going to be defined in the interval. But as we can see here, both the sequence and the function, they're heading to the same place, right? The only difference is that the sequence is only comprised of dots at the natural numbers, so 1, 2, 3, 4, 5, and so on, whereas the function is defined continuously between the points. So once we realize that the limit of a sequence can be defined using the limit of a function, we're going to turn this into a function. So we're going to say this is equal to the limit as x approaches infinity of x squared over e to the x, right? And then we're going to use L'Hopital here. So we're going to take the derivative of the top and of the bottom, and we're going to differentiate it. So we're going to take the limit as x approaches infinity of derivative of x squared is 2x over the derivative of e to the x is just e to the x, and this is still equal to 2 times infinity, that is infinity over e to the power of infinity, also infinity. So once more, we have an indeterminate form. We can use L'Hopital again. So we're going to say use L'Hopital, and then we're going to take the limit as x approaches infinity. The derivative of 2x is just 2, and the derivative of e to the x is e to the x. So this is going to be 2 divided by infinity, right? And 2 divided by infinity, that tends to 0, because anything divided by a very large number, a finite number divided by an infinitely large number leads us to 0. So once we have determined that this limit is 0, we can say here that an, so our sequence that was approximated, whose limit was approximated using the function, an tends to 0 as n tends to infinity, so an converges. And that is it for number 41.